What's up, guys? Derek here, coming at you from my new house. Just going to make a little video showing you how I am going to use the C++ program I wrote to 3D print a custom pigeon feeder for my pigeons. I want a small feeder with a really large base so I can ration how much feed I give the pigeons at any one time, but I also don't want it to be tipped over if they fly down and land on it. And this will make a lot more sense when it's done, so just bear with me here. Let's get right into the coding. So here I am in code blocks. I will be doing the main coding here in the main CPP file. I've got a whole bunch of old projects down here that I like to reference back to, but I will be starting with a clean slate here. And then here's my shape generator. I don't know what this FF, I don't know what that was, but I got my shape generator files, which basically include all the code, and I'm not going to go super in depth in that. I'm just going to show the basics of how I use it. So the first thing I'm going to do is create a shape object. So I'm just going to add an object to the vector. So I just resized the vector to one more. So now we'll be doing the rest of everything on the object in the back of that vector. So first thing we will do is set the total height of the object we want to make, which I want it to be 25 millimeters. So I'll do just like that. And we're going to be using this object a lot, so I'm just going to copy it so I can keep pasting it. So the wall line count, I want thick walls, so it's pretty durable. So I'm going to make it 4 layers. And then bottom layers, I want 4 bottom layers is usually also what I go with. Got that copied. Top layers, we'll have no top layers because obviously if we want it to be a dish that can hold something, there can't be a top on it. And then finally infill has to be 0 because we want it to be hollow and to be able to hold things. So the next thing we'll have to do is create the initial plane, which is how large the base of the object is. And we're going to create a new plane at 0 millimeters. So the bottom plane. And now I'm going to have to create a for loop. And we're going to write this once and then copy and paste it multiple times throughout this code. And it's just to make a rather general round shape, basically. So it's just going to be a for loop, doing some trigonometry. And then we'll make it equal. Well, 20 sides per circle. So it's just a circle that does a full rotation from -pi to pi, and there'll be a point every 20th of the way around the circle. And within this, we want to create a point on that plane each time we go through the for loop. So we're going to do a new plane vertex function. And first, we're operating on plane 0, as you can see right here. And secondly, we want to do the coordinate for the point, which will be an x and a y coordinate. And if you remember your unit circle, cosine comes first, sine is second. So we're going to do cosine of theta. I want the base to be, let's say we want 150 millimeters diameter. So we're going to do 75 for the radius. We'll put it in the middle of the print bed. And then we'll do the same thing times 75. We'll make it a perfect circle plus 110 again. And I don't know why I put a parenthesis there. There we go. That's all we need in this for loop. And now we're going to copy and paste the same for loop again, except this time we're going to start at 5.2. And now that the base is done, we're going to start with the dish itself. And this dish, I don't want it that big. I decided ahead of time I want it 5 centimeters in diameter. So that's 25 millimeters each way. So now we are creating, and I got to make sure to update that to the next plane. So now the object is drastically reduced in diameter. And finally, I just need to finish that out to the top. And now the top of the cup, I'm going to put at 25 millimeters or 2.5 centimeters. It's going to be a pretty small dish. It's only for 2 pigeons. So type today at 25. But rather than just have a straight line connecting, I want the bowl to have a little bit of a bevel to it. So to do this, I'm going to use a line shift, which is another object that you can create using my namespace. So I'm going to name this the shift. Now I don't have to put in any points. I'm going to specify how I want each point to be shifted on each layer, and it will just be using the points from this layer and shifting them layer by layer up to 25 millimeters. So I'm going to put that right in between here, and I'm going to create a line shift object, and I'm going to name it shift like I specified below. So it's not going to be a straight shift, and that equals 0. I just know that because I wrote the library, and that could be made a little, that could be clarified, but I haven't done that. And then next, I'm going to specify where the center of the shift will be. And I've been using 110, 110 as the center for everything prior to this. So I'm going to stick with that. Next, I'm going to set shift radians to m_pi. This is another artifact of different types of shifts that we're not going to be using. You can just ignore that. And now we're going to set a sine wave to the shift because we want it to be a curve. And a sine wave is how I do this, because then you can also do wavy sides to objects. So I want it to curve out enough that it's noticeable but not be super large. So I'm using 30 millimeters for that. I can't really explain why. I've just done this enough that I know that's about what I want. The wavelength, I want to be large. I'm going to do 10 centimeters, which will be well more than the total object because I don't want it to bevel back in. I just want a little bit of that gradualness. And then the start point will be 0. You could hypothetically start it at like 1 pi, and then rather than going out, it'd be coming in, stuff like that. Yeah, so now I'm creating this object that's using a shift of these points through this much of a shift, and then it's outputting this layer. So this is the final layer here. Now, the last thing we need to do is set some fill ranges because we want the base to be solid and we don't want feed to be able to fill into the base, but we don't want to waste too much filament on that. So I'm going to show that here. So we've already set the bottom layers. So the first fill range will be the interior infill of the base, which is from 0.8 to 4.2 millimeters. So gen shape.back. Like I said, we're always working on that one object. The way the program is written, you could have multiple objects created in one GCode file. That's not important for us here. So we're going to create a fill range. And we're going to start at 0.8 because if you remember, we have 4 bottom layers, and then the defaults for layer height, you can see are 0.2 millimeters, which I have set in the library. So 4 times 0.2 is 0.8. And then we're going to also want 4 layers on the top of the base. So I'm going to do 4.2 as the top end of the range. And let's use 15% infill. So now that's set. Next, we're going to set some thick layers here, or some solid layers, I should say, for the top of the base. Copy and paste this line down. And I'm going to start at 4.2 and end at 5. I want that to be solid, so that's 100%. So after that, I had already specified no infill. So above 5 millimeters, starting on the actual pigeon dish itself, there will be no infill anymore, only the exterior walls. All right, so now we're ready to run the program. I'm going to click this build and run. And we get an error here. And I put a plus sign instead of an underscore in the macro for pi. So I'm going to quickly correct that. And then I wrote sign with an E right there. Forgot one more period. What I get for trying to go too fast. And now here we're finally running it. So now I'm going to open my Octoprint and send this file to it, and we'll visualize it in 3D before it prints. Anyways, we'll go over to Octopi. And I'm going to scroll on down here and upload. Then I'm going to search my pigeon feeder, GCode. As you can see, it's there. So I'll scroll down to the M's, my pigeon feeder. And that's uploaded. The print just finished. Here it is. Haven't even peeled it off the plate yet, but turned out pretty good. I'll peel it off the plate and we'll go test her out.